Good morning, ladies and gentlemen. Welcome to Math 20-1, Chapter 4, Section 1, Properties of Quadratic Equation. Now, we're dealing with quadratics here. That is a second-degree polynomial. Polynomial means more than one term, or at least one term, and second means second degree. Second degree squared, not a cubed, a squared. Now, one other thing to note here is that with your quadratic, you have ax squared plus bx plus c is your generic quadratic equation. A, b, and c are real numbers, not imaginary. So they should be nice numbers like 7 or 3 or 2, but you can't have like square root of 5 or pi, just to confuse things. Anyway, important stuff. Grab your graphing calculator, and I do mean grab it because you need it. So I want you to graph x squared plus 2x plus 3. Now note with the windows, I want the window set minus 10 to 10 for x and minus 10 to 10 for y. So I'm going to pause the recording while you grab your graphing calculator, and I want you to graph it. Actually, I'm going to erase you because x squared plus 2x plus 3. If you go to your graphing calculator, y equals x squared plus 2x plus 3, enter. And I'm going to check my windows. By default, I want you to use minus 10 to 10, x minimum minus 10, x maximum 10, x scale, that is a tick mark at every 1, y minimum minus 10, y maximum 10, y scale should be 1. What's going on here? Nope. Y scale should be 1. Never mind. As for the rest of it, that's technical stuff. Don't worry about it. Now this is the default stuff I want to see. And oh, the little minus sign here is the negative sign down here, not minus here. Okay, see the difference? That confuses Mr. Calculator. I need the little minus sign and 10. Enter graph. And there we go. That's what I got. And so x squared plus 2x plus 3. Now, where's the vertex? Now, the vertex is the bottom part here. So you go to your table of values. What's the bottom part? Oh, sorry, I should be showing you on the table here. Second table. And we're going, where's the bottom part? Ooh, right here. X is minus 1. Y is 2. That's the lowest part, because notice how it goes. X is 0. Y is 3. X is minus 2. Y becomes 3 again. So minus 1 and 2 is my vertex. Morning. Okay, so the vertex is minus 1 and 2. Now, domain are my x values. In this instance, x is all real. That little e thing, that's Latin, I forget. It's something about all. Another shortcut you're supposed to remember. Now, the range are your y values. Notice here it goes down to plus 2 in your graph. So y is greater than or equal to plus 2. So this is the important stuff for this lesson. Can you graph it? Can you find the vertex, domain, and range? All right? Now, and keep your windows minus 10 to 10 unless I say otherwise. So far, so good? All right, good. Now, if you do not have a graphing calculator, you have to use a table of values. Woohoo! Now I'm just going to start that with you. Minus 3 squared becomes plus 9. 9 plus 9 minus 6 becomes 3. 9 minus 3. Let's see now. 2, 3, sorry, plus 3 is 6. Minus 2 squared is 4. 4 plus 4 is 0. 3. That's not right. Hang on, what am I? Hang on, now let me check. 1 minus 1, 2. Never mind. Can't do this in my head anymore. 0, 0, 3. Anyway, there's our table of values. Getting old. Right here from Mr. Calculator calculated for us. I expect you to be able to do that if you haven't got a graphing calculator. Yes, that sucks. Get a graphing calculator. All right. Now, next thing, intercepts. Now the x-intercept is where the graph crosses the y-axis. Here you set y equal to 0 and solve for x. All right? Now I want you to note here in the previous graph, it didn't cross the x-axis. So we'll do this as an example. Actually, let's skip on. X-intercept. What are the x-intercepts of y equals x squared plus 8x plus 15? So you set y equal to 0. Anytime you see x-intercepts, y is 0. So 0 equals x squared plus 8x plus 15. Right? Now, when I say solve, you have one of two ways to do this. Last chapter, I'd ask you to solve the equation. Excuse me. Factor. And there's a two x-intercepts for this equation. Right, now that's the one way to do it. But what have I been talking about here? Graphing. So I want you to graph y1 equals x squared plus 8x plus 15. So I'm going to pause the recording. I want you to draw the graph and see where it crosses the x-axis. Okay? When I graphed it, I got that. X equals minus 5 and x minus 3. Now how do I know that? Well, I went to my table of values. Actually, I should just show you, it'd be easier. Y equals clear x squared plus 8x plus 15. Enter. Graph. There's my graph. Go to my table of values. I'm looking for when y equals 0. Right here. X equals minus 5 and x equals minus 3. All right? So that's how I find my intercepts. Minus 5 and minus 3. So last chapter, solving it, we factored. This chapter, we can graph it. Now, I want you to try the same thing for the x-intercepts of y equals 2x squared plus 12x plus 21. All right? So 2x squared plus 12x plus 21. Let's try that. 2x squared plus 12x plus 21. And did I get that right? 2x squared plus 12x plus 21. Yes, I did. And where does that cross the y-axis? It doesn't. Woohoo! None. You cannot factor it. If you want to check the discriminant, remember b squared minus 4ac, 12 squared minus 4 times 2 times 21. Right, what's 8 times 21? 168. Negative 24. No solution. So I could just graph it and say there are no x-intercepts. Last chapter, you'd have to find the discriminant. Realize it doesn't work. So it's easier. Graphing, if you have a graphing calculator. All right? So far, so good? Now, definition I skipped over. Oh, you poopy head, stop that. Stop that, guys. y-intercept, where the graph crosses the x-axis, set x equal to 0 and solve for y. Now, let's look at these two graphs. What are the y-intercepts? Do we know? Do we care? Well, they're easy to find. How do we know? Well, we go to our table of values. And what's x when x is, what is the y value when x is 0? In this instance, the last one, it's 21. Now note that carefully. Where else have we seen 21? It's the constant value. Because if x is 0, we're down to the constant value. Y-intercept, x is 0, is 21. Should stress that here. It's the constant value in the equation. So if I go y equals minus 3x squared plus 7x plus 11, what's my y-intercept? 11. If the equation is y is equal to x squared plus x, what's my constant value? Plus 0. Okay? So that's how you find the y-intercept. That's easy. Okay? Now, moving on, I want you to graph this equation, x squared plus 2x plus 3 again. And I want you to do vertex, axis of symmetry, domain, range, direction of opening, y-intercept, x-intercepts. Now, you've seen this equation before. I want you to do it again because I want to talk about direction of opening and x and y-intercepts for this one. Now, you'll note here, I said from -3 to 3. That's for people that don't have a graphing calculator. You have to do a table of values. And I want you to do the table of values from x is -3 to 3. Since you have a graphing calculator, just set your windows -10 to 10 and do it, please. All right, let's go. Actually, you do it and pause the recording, come back, and we'll check. Okay, this is x squared plus 2x plus 3. We've seen it before. Surprise! It goes something like this. Now, as we said, the vertex was... Let me bring fart here. What I just saw it in the table of values. I'm getting too old. Table of values. -1 and 2. Now, the new thing is the axis of symmetry. This goes back to the good old days when we didn't have a graphing calculator and we had to do a table of values. There are tricks to find the vertex, and then we would just draw a line through it and reflect our table of reflect the graph we drew. So we would draw half the graph and then reflect it. Remember back in grade 3 or 4 you had the little red plastic mirror things for reflections? This is it. So the axis of symmetry is your x value. So literally in the old days you'd only have to do half the table of values and then you just reflect it, or half the graph and reflect it. As we were saying earlier, sorry, give that a moment, sorry, getting ahead of myself again, I apologize. Note the axis of symmetry. Definition you have to remember. Now domain, x is all real. Range, y is greater than or equal to 2. Your bottom of your vertex. Direction of opening. This opens up. Smiley face. The y-intercept, that is when x is 0, the y-intercept is equals +3. X-intercepts, there are none. Does not cross the x-axis. Okay. So far, so good. Now, just a reminder, the x-intercepts, last chapter we called those the solutions, or the zeros. I'm going to try to remember to call them x-intercepts this chapter. Now, I want you guys to graph this one. -1/2 x squared minus 2x plus 2. If you have not got a graphing calculator, I expect you to do a table of values for -3 to 3. So graph it, come back, and we'll talk about your answers here. Okay, ladies and gentlemen, when I draw the graph, I get this. Okay, so it goes something like that. Now, the vertex, where's the peak? Crap, that's a good question. So we go to our table of values. And where is our top? Ooh, it looks like we're lucky. We get a symmetrical one at 0. X is 0, y is 7. We're lucky there. Now, vertex is, which makes axis symmetry, x equals 0. Now, here's a problem. All right, so everybody stop here, take a good look at this. I want you to go back to your graph and go, notice how that is symmetrical, so we're at the peak. Actually, I've checked. I know that is the peak, but I'm going to show you how to double check that, okay? So pay very careful attention. Second, calculate number 4 maximum. If we're looking for a valley, we would do number 3 minimum. But number 4 maximum, enter. Now Mr. Calculator is saying left boundary. So you go to the left of the peak. Doesn't matter where. Enter. Notice the little arrow here saying going to the right. So next thing is right boundary. So we have to go to the right of the peak. Enter. It's going guess. Is it this peak? Are you sure? Are you sure? Are you sure? Yes. Mother Kazad. Now, y equals 7. X equals minus 6.947 e to the minus 7. Okay? Mr. Calculator is calculating this at minus 6.9 times 10 to the minus 7, or 0.00000, minus 0.069 something. All right. That's Mr. Calculator speak for 0. It's having trouble. It's making a rounding off error somewhere. All right, so the minimum is 0 and 7. Okay. Oh, sorry, the maximum, my apologies, is 0 and 7. Remember how to do that. Now, because I will be giving you graphs that aren't so nice. Now, what's the domain of this? Our x values. X is all real. It's always all real for quadratic. What's our range? Well, right here, it only goes to 7. So y is less than or equal to 7. Direction of opening is down. Remember, this is negative, so it's a frowny face. The y-intercept, y equals 7. Now, the x-intercepts. There are several ways to do this. Last chapter, we would set this the equation equal to 0 and solve it. This chapter, we have a graphing calculator to do this work. So I'm going to show you the easiest way. Second, calculate number 2 as 0. So notice what's saying the left bound. So I want to be to the left of the 0. Enter. And then I scroll over down to the right of the 0. And Mr. Graphing Calculator will calculate that as 3.74165 or 3.7. I'm willing to bet that's plus and minus because it's so symmetrical, but I'm going to double check. Second, calculate number 2, 0. I have to be to the left of it. Keep going. Come on, to the left. Now, what they're doing here is your y value has to change from positive to negative or negative to positive. Now I'm to the right of it. And minus 3.416. minus 3.74. I should probably go to 2 decimal places because I can't. Now, if we use the quadratic equation to solve this, we would get plus or minus the square root of something divided by something. I'm not going to bother calculating it because I'm lazy. That is how you would calculate the decimal approximation. All right? Yes, now don't you wish you'd known this last chapter? Okay. So, one more graph. 2x squared plus 12x plus 21. And once again, if you haven't got a graphing calculator, do a table of values. Go. We've done this before. So you guys graph it. We'll come back and compare graphs. Let's go. Okay, guys, this is my graph. It'll look something like that. Now, we've done the vertex before in the axis symmetry, but let's go double check it. How do we find the vertex here? Well, if I'm not certain, let's calculate the minimum, number 3. So I have to be to the left of it. There I am. Enter. And then I have to scroll over to the right of it. Enter. Guess. Yes. So minimum minus 3 and 3. Okay. Now this time the calculator's getting it exact. No rounding off errors. Woohoo! So vertex is minus 3 comma 3. So my axis of symmetry is x equals minus 3. The domain is, once again, x is all real. The range, since this is plus, it's going up. Y is greater than or equal to 3. The direction of opening, as I said, since it's positive, it's up. The y-intercept is my constant value, 21. And my x-intercepts, there are none. Okay? So that's how that goes. See? Now, any questions so far? So if I give you the equation, you can graph it. You can find the vertex, the axis of symmetry, domain, range, direction of opening, x and y intercepts. Now, one last question for you, or actually 2 parts. The stopping distance d of the LRT in Edmonton depends on the speed s according to the formula d equals 0.08 s squared plus 1.76 s plus 0.02, where d is distance in meters, is s in speed in meters per second. A, what's the stopping distance of the LRT when it's going 20 meters a second, and what was its speed if it stopped in 55 meters? Now, how do we solve this? Well, what I need you to do is graph the darn thing. So, y equals 0.08 x squared. No, oh, you shazbot. Clear. Sorry. 0.08 x squared plus 1.76 x plus 0.02. Enter. All right. Now, you graph this, you get something like that. Now, of course, we're going to graph it. Now, my problem is, how does that help us solve the question here? Well, what's the stopping distance of the LRT if it's going 20 meters a second? Well, part A, actually, part A, x is 20, what's y? Look at our table of values. That's easy. Actually, that's too easy. Second table of values, x is 20. .22 meters. Sorry, I got 67.22. Now, why did I draw the graph? Well, that's actually for second question is more important, but it's actually good for both. If this is speed and this is distance, here the problem is we don't care about negative speeds and we don't care about negative distances. We only care about when it's positive. So when it's going like this. So for this, the domain, x is greater than or equal to 0, and the range, y is greater than or equal to 0. So that's a trick here, but I want you to realize, oh, when I draw the graph, I don't care about negative speed. I only care about positive speed. So I have to set my windows. When I draw this graph, I'm going windows, 0. Now, what did I say x is? X is speed. So it's going 20, 30, let's go, I don't know, 50 kilometers an hour is the maximum. So if it's going 50, let's do a tick mark every 5. Now, stopping distance 0, I have no idea. Let's guess 200 meters. Let's put a tick mark every 10 and graph. Oh, that's pretty good. There we go. Woo-hoo. So you have to play with your windows so you can see your graph. Remember here, I was nice and I said, if you don't have a graphing calculator, do the table of values from -3 to 3. Yes. That would give you part of the graph and you have to figure out the rest. Now, I was going to say here, going back to this graph, the important points are you have to play with your domain and range. Now, the last question, what was the speed if it stopped in 55 meters? Well, displacement is 55. What's your x value? Well, how do you do that? Well, remember the beauty of graphing calculators? y2 is 55. Graph. Ooh, we have 2 lines, and they intersect. Can we calculate an intersect point? Ooh, yes, we can. 17.429738. Woohoo! At 55 meters, at 17.4 meters a second, it takes 55 meters to stop. Woohoo! The beauty of a graphing calculator. If you know how to use it, it's powerful and it saves you a lot of work. If you don't, then you're doing table of values and this poop load of work. Good luck. Any questions? So, you know how to graph, you know how to find domain, range, direction of openings, x and y-intercepts, the axis of symmetry and the vertex, intersects, and, if necessary, you know how to play with the windows. Play with the windows of the graph, all right? That's what I need you to be able to do. So, try 4.1, check your understanding, and I'll see you in class tomorrow. Good luck.